I got to free up some space to set this recording. Let's see. They're saying I need a little more space to get the recording. Let's see. Webinar. So I'll just free up a little space. Start it. Okay, we're good to go. Let's start it. So, hi everyone. This is Rob Canzaneri, and I'd like to welcome everyone to the Data Architecture Chapter meeting this month. I really want to thank Robert Bishop for being very flexible and coming on today. I emailed him kind of early on this month, and he said he would come on. So first of all, big shout out to Robert and thank you. And I also like to thank Kenneth Neal, who has been really great helping me with these meetings lately. If y'all have any questions or y'all want to contact me, my email is rob@sqltigers.com, and I also have a website there, www.sqltigers.com. Today we're going to have Robert on here, and we're going to talk about index and execution plans. So it's really important. We got a code here, and if you use this code, it'll save you money at the summit. And if we get enough people using the code, we can auction off, or not say auction, we can have a raffle, and the raffle will give away a free session, as I understand. So for the summit, for this $2,100, $2,195, which is amazing. So if you're going and use the code, I appreciate it. Thank you. So upcoming SQL Saturdays. They got in June. You can't hear me? Oh. Can you hear me now? Can people hear me?
I can, Rob.
Okay. Can you hear me? It must be you. All right. So it's good. I'm glad everybody's hearing me. I thought we had a little problem there. Sorry about that. Anyway, we've got some upcoming SQL Saturdays, and one in Baton Rouge, and Robert's going to talk, and I'm going to talk. And so if you're in Baton Rouge, I really highly encourage you sign up and come to the August 6th Baton Rouge SQL Saturday. We'll look forward to seeing you, and say something if you're here and you show up. I'd love to see talk to y'all. With that, I'm gonna turn it over to Robert, and he's gonna start his presentation. But before, one quick thing: this is recorded, and I will put it on the Data Architecture website for pass. And at the end, if we have time, we can take some questions. So we'll just see how we're doing time-wise, so hold your questions to the end if you don't mind. Just make a note, and we'll open it up, and we'll make sure what questions don't get answered. I'll email Robert and make sure he gets them, and we can kind of get you some answers hopefully. Thank you. So Robert, thanks for coming on.
My pleasure. Thank you everybody for having me. Good afternoon. I am Robert Bishop. I am a senior SQL consultant for SparkHound here in Baton Rouge. You can find me at SQL_Padre at Twitter, and I blog at SQLPadreWordPress.com. Today we're going to talk about index and execution plans. The premise of my whole presentation was I read a blog from Tim Ford about the entry-level challenge. Bottom line, everybody starts somewhere. So his challenge was to have everyone blog an entry-level blog once per month. So I created two presentations. You'll see the other one is called a hostile takeover, which I will do at SQL Saturday, but this one is concerning indexes and executions. Topics for today, we're going to discuss basic terms, how to read an execution plan, using execution plans to determine indexing strategies, and a simple script that will show you how to see if those indexes are effective. So some basic terms. Index. Bottom line, it is what SQL uses to look up something in an organized way. We have two primary types of index, a clustered, which is an ordered index. That is how the data is actually stored on the physical hard drive. And then we have non-clustered indexes, which uses pointers to determine where the data is located on the drive. And then we have execution plans. They can be graphical, they can be text, or they can be XML based. But they're representations of how SQL runs your code. The things that we commonly look for in execution plans are what we call scans, seeks, and lookups, and compile warnings. These things are what indexes use to find data. They'll either scan the data, seek it, or do a lookup. So exactly what is a clustered index? It is basically how it is physically stored on the disk. It's best practice for it to be unique. But if it's not unique, SQL Server has a tendency to hide a hidden column to make it unique. So you might as well go ahead and make it unique now at the beginning so you don't have to add additional weight to your data. Typically, and by default, your primary key is your clustered index. But does it have to be? We'll look at it later and see if the clustered index can or cannot be your primary key. What is the most common primary key used in data that I see? And it's usually an ID column with an identity integer data type. This is an example of an index. It's a typical phone book, but if you look at the highlighted portion on the top, it says WAG-we, which tells me everything on this page is going to be within those ranges of those letters. It's going to either be a WAG or WEE. This is a simple example of a clustered index for a data page, because I know if I'm looking for Walter, it's going to be on this page. So some column considerations for clustered indexes. You want as few columns as possible for your clustered index. You want to make sure they're unique and contain many distinct values. It makes it a lot easier for SQL to find it if the clustered index is unique or distinct. They need to be accessed sequentially. That's why the ID column, the integer column, is such a common use for an clustered index in a primary key, is because the data will be stored 1, 2, 3, 4, 5, 6. Defined as an identity. It should be defined as an identity so it can be sequentially. And you need to use clustered index are used frequently to sort the data retrieved from a table. It's recommended to not use columns that frequently change. In other words, an age column will change every year as a person gets older. It would not, if that was your clustered index, then every day the data would physically change on the hard drive, which causes major overhead on your server. And you don't want many columns as your clustered index. You want as few columns as possible. Query considerations for clustered index. They typically return range values using the operators between, greater than, less than, stuff like that. They typically are good at returning large result sets. And they use join clauses typically, but they use foreign keys to help with those join clauses. Clustered indexes are used in the order by and the group by clauses. So what is a non-clustered index? It is stored separate from the actual data. It can even be stored on another disk. I had a server one time where I had many non-clustered indexes that were stored on a separate disk to allow for easily write and inserts and updates. The non-clustered index use pointers to the clustered index. Every non-clustered index in the background hidden is the clustered index. This would be an example of a non-clustered index. This is a page from a cookbook that shows appetizers, beans, and beverages. So if I put a non-clustered index on the appetizers, which we would call it, let's say, category type, and I query against that, it would be a lot easier for SQL to find all the appetizers. Non-clustered index considerations are one or more columns that can selectively identify a row or a group of rows. It does require additional space for your hard drives. Because this is overhead, it does require additional space. And the non-clustered indexes always include that extra row locator, i.e. the clustered index. Large volumes of data with minimal updates are excellent candidates for non-clustered indexes, data warehouses, or reporting servers, data that doesn't change a whole lot. The OLTP, online transactional servers, need to minimize the use of non-clustered indexes because the insert updates and delete and merge commands are affected every time they're used. For every insert you do on a row, if you have 5 non-clustered indexes, it has to write to the table or to the database 5 times. So it's overhead on the server. Non-clustered indexes are used typically in the joins and the group by clauses. They're good for queries that don't return large result sets if you're trying to get those minimal results. Non-clustered indexes are frequently used in where clauses, and you want to do what we call cover the query, and I'll explain that in our demos here. But you want to be able to create a non-clustered index to handle multiple queries. Non-clustered indexes could be distinct values, and you can use multiple distinct values. So our execution plans. What is an execution plan? It is used by the SQL engine to execute your queries. It is XML-based that allows SQL to map out how it's going to retrieve the data from the database. It basically tells SQL what to do. But more importantly, it gives you a description of what SQL does with the query. It can be presented graphically, in text, or in XML format. So reading a query plan. How do we read a query? An execution plan. For me, you have to kind of know how SQL operates a query. It starts with the from, moves to the join, the where, the group by, and then it will execute the having, select, distinct, top, and order by. This is the order SQL will perform your query. So if you have a huge query with multiple joins and all these things, the first thing it's going to do is hit the from statement. And then it's going to get to the joins, and then it's going to filter out the where clauses, and the group bys, and the havings, and then it will actually do the select last, unless you have a distinct top or an order by statement. So this is kind of how you would want to read an execution plan. Here's a sample execution plan. If you notice in the top left, there's the select statement. And typically, we read left to right. I personally like to read right to left when it comes to execution plans. There are some individuals out there in the SQL community that will say you read it like you read a book. But I prefer to read it from the right to the left because it's the beginning of your query. The order of the query is executed. We see the non-clustered index, and we see the clustered index scans, and then it moves to the left to the select statement. Things to look for in your execution plan. You want to kind of look for the I/O cost, the CPU cost, subtree cost, the number of rows, and the row size. And I'll show you where to get all that information. You want to look at the ordered. Is it ordered? You want to look at the predicates and the output list. These are all things that are very important to figuring out your indexing strategy using execution plans. These are some of your typical operators that you'll see, the pretty little graphs. If you notice, there's different pictures for scans, seeks, and there's filters, tops, sorts, key lookups. These are all the different types of operators that you can see. Some are good, some are not so good, some you want to try to do your best to stay away from. So let's get into some demos. Earlier I created a database called Phone Book, and it just has some tables with phone numbers, first names, last names. And so let's look at the first table called the white pages. When you execute this, we can see that the first column is an ID column, which is my primary key clustered index. And then, of course, we've got names, street address, cities, and phone numbers. This particular table does not have, the ID column is still the identity column, but it is not the clustered index. And this is the example I was going to say. This is the clustered index. Because phone numbers are unique values across the country, we can set this up this way for this example. You notice the ID is not sequential, but the phone numbers are. It's just a simple example. A unique non-clustered index, which is not the primary key. This is still my ID identity column. It will be unique per every row, but we've set this up to be sorted by city and state. And if we look at the way the table is actually designed, so number 3, we can see that the primary key is on the phone number, and the identity column is still set to the ID. So let's take a look at our first index and our query. We're going to find a simple query that finds everybody with the last name Smith and the first name Robert. So if I use this and I look at the execution plan, which can be turned on by this little icon or the Control M tab, and I hover over a pretty little icon and I get these little boxes. But it's really kind of very hard to keep the boxes up because they constantly move. This is the one and only time I ever use, or I've ever found a real need to use the properties table in SQL Studio, Microsoft SQL Management Studio. Because everything in the yellow box is presented in the properties tab when you click on the box. So we're going to start with the clustered scan, and we're going to look at the predicates. The predicates are what you're searching for. If you notice, it says where last name equals parameter 1 and first name is parameter 2. We're also going to look at our output list. This is what the query is actually sending to the next stage in your execution plan. It's looking for the last name, first name, city, and state. Well, that's good, and it looks like it could work, but we know with indexes help speed up processes to find data. So looking at this cost, and this is the subtree cost, and this is a number that is generated by SQL per machine that tells you how much work SQL had to do. It is not standard across the board, it is just per machine. So it's 2.06, which I've recorded here. So let's create a non-clustered index based on the last name. because I know I'm looking for last names. So I'm going to create that, and we're going to see what changes in our execution plan. I still have my 2 people, and it doesn't look any different. If I look at the subtree cost, it's still 206608. Nothing's changed. It's still index scan. Well, if you notice the operators from earlier, we have scan, seek, and lookup. Seek is what you're targeting. Seek is what you want to find. That's because SQL knows where to find the data, and it can just bounce around and look and seek for the pages. A scan means it has to take one or more of those data pages and actually read it to be able to find your data. So we're looking for a seek. But I'm also looking for first name. So let me see if I add the first name, would that help my query? We run it a third time. Uh-oh. I think I've complicated matters because now I've got another operator in my query plan. But I can see by here that it did use the NCI demo index. It was based on the seek predicate of the first name and last name. So it's looked for what I wanted it to look for, but apparently it had to go back to the table to find something. So what did it have to find? Let's look at the output list to see what this operator is outputting to here. It's getting the city and state. Interesting enough, the way SQL works, when the index is first used, it will find the data that you're looking for, the Robert Smiths. And then once it finds that, it has to go back to the table using that hidden column of the non-clustered index, which is the ID of the table, join back to it and pull out the city and state. So this didn't help us at all because our operator cost now is a little better, but I think having more operators can make it more difficult. So how do we include the city and state in our queries and in our indexes that will help my query run even faster? The hint there was the include statement. So if we include the city and state in the index, let's see if it'll help us out. Oops, sorry, highlighted too much. Now if we look at the index plan now, our lookup operator has disappeared. We have a nice clean output list of the 4 things we're looking for in our select statement. And our subtree cost is now down to 0032833. That's pretty much as best and as fast as you're going to get this query on this small amount of data. But as we all know, developers love to change queries. So what happens if they say, oh no, we need the zip code now? If you run that query, if you'll notice, the lookup comes back. The key lookup comes back because what? It has to go back to the database, the table, to find the zip code. So let's add the zip code to our index. And if we run it one more time, we'll see that the key lookup has disappeared because we have included the select columns that are not indexed into the include statement. But this is what we call a covering index. If your developers decide, I don't need the zip code after all, we're going to just go with the state. Because if I run this without the zip code, it's still using the NCI Demo 1 index. That happens to include the zip as well. And if you come down to this simple query of just first name and last name, it's still going to use the same index. These are what we call covering indexes. You want to plan your indexes to be able to cover as many queries as possible. So does the order of the index columns matter? I've switched it to where the where clause is Robert is the first name and then last name. Is this going to make a difference in our queries? Doesn't look like it. It still uses the same index and it still has the same subtree cost. But what if we change the order of the columns in the index? The previous index had last name first, then first name. Will that make a difference? And as we can see, it does not. We're still using the same index, and we're still going to get the same subtree cost. So some of the ways we can look at and see the kind of information we need to evaluate these indexes. The command set show command set show plan text will give you the actual text of what is happening. It is an index scan on the phone book white pages table of NCI Demo 1. This is just another way to get the information you need. And if you wanted to show the XML portion, if you do this, it'll come up with this nice little link that you click, and you get the graphics, and you can go to the XML, which actually will give you the same thing that is in the graphical plan. It's just in an XML format. Another cool, very helpful tool in evaluating indexes is what we call I/O statistics, and I'm going to clean out my memory, my cache for this. This is not something you should ever do in production. This is something I'm just doing in demos to show you what I/O statistics can look like. So I'm going to search everybody in the white pages that live in Louisiana. And if I run it the first time, and I look over here on the message tabs, it tells you what the query did. It did a table scan with logical reads of 128 and physical reads of 1. Physical reads is what you need to look for. That means that SQL actually had to go to the physical hard drive to find the data. The data was not in memory, so it had to go look for the drive. And if I run this again and look at it, physical reads is now 0 because the first time I ran it, after clearing out my cache, SQL put that data into memory, and so now I can read it straight from memory. This is very helpful in large data warehouse queries, so you can kind of get an idea of just how much physical reads the query has to go through to get your data. Because we all know memory is much faster than data. Another way you can help time your queries is with set statistics time on. Using this one, it'll flat out tell you how long it took to run the query. And if you look here, it took 2 milliseconds with 0 CPU time. But let me clean the cache and see if that makes any difference. It sure does. When the data is in memory, it runs faster. Just like if the data is in memory, the IOs are lower, your processing time will be lower as well. And if you use both of them together, it can be a pretty neat tool to determine how fast things are going. It took 125 milliseconds, 0 physical reads, and it was a fairly quick and easy information. So let's go a little deeper on the demos. So we have a yellow pages as well, and I have them. They're all companies, and they have a company type of radiology. So if I look at the radiology group, and I forgot to include execution plans on, And we look at it and we see that it's using the primary key and it's costing us 12.12. Well, knowing what I know now from the white pages demo, I'm going to put a non-clustered index on the company type and include the other columns. So if I do that and I run my query again, we see that it is a single operator with the select statement and it's down to 0.007. Cut this drastically as far as time it takes to run it. I'm going to clean out my cache one more time for the next one. And so we're going to do sorting. Does sorting affect indexes and executions? I'm going to run both these at the same time with the set statistics time on, and we'll see what happens. So the first one is ordered by company, and the next one is not ordered by. So it should be unsorted. So this one's sorted, this one's not. Let's look at our messages. This one's sorted, which took 187 milliseconds, and this one is unsorted, which took 100 milliseconds. Sorting is overhead on your queries. If your queries are running long and you have a bunch of sorts, my recommendation is let the application do the sorting, not SQL. So I've added my included columns on this index. Make sure it's the right index. And I'm going to go ahead and clean out my buffers one more time. That's a duplicate. So we're going to get a little complicated. So this one is the yellow pages, and I'm going to join to the white pages based on the yellow page ID. And I'm going to sort or look for companies that are basically medical fields in the state. And I'm going to order it by company type and then company name. So let's see what my results comes in. Invalid object, yellow pages. Helps if I set the right. All right, so we've got all the medical company types, all the company names that are in Louisiana. So let's look at our execution plan. It's a little bit not too difficult, not too bad, but we do have two scans, index scans, which we are okay but not the greatest because we really want to see those as index seeks. But we also notice SQL up here in this pretty green thing that's very annoying when you hover over it. So quickly put missing index details. This can be your possible solution. I warn against it, using it as is, but test it. Most of the time on simple queries, SQL can get it right. But the missing queries SQL does not take into account queries that are currently on your system when it gives you hints for missing queries. So if you've got another query index on your system that's close to this, you might need to adjust that one to cover this new query that you're writing or change the index just a little bit. But for my case, this is exactly what I kind of need. So I'm going to come back here to my index. I'm looking for, because I'm filtering on my where clause by my company type. I'm going to use that, and then I'm going to give the rest of the information here in the include. So now let's see how our indexes and execution plans work. Well, that didn't seem to help. We still got we've got one seek, but we have one scan. But what is it telling me now? It's saying it needs a yellow page ID non-clustered index. Why would it need that? If I look at the query plan, you notice that this operator and this operator have to join together to make this. To do that, let's say this is a join. It's an inner join. So if we come back to our query, this is our inner join. And we're joining on the yellow page ID. So basically what I have to do is find an index that's going to use the yellow page ID and return the values that are in the select statement, to include those values that are in the select statement. Because I'm using two tables, this SQL is requesting two different queries, or two different indexes. So I'm going to add this to the white pages with indexed on the yellow page ID with an include statement as well. And now let's look at our query and see how we look. Now that looks pretty good. It's an index seek using my non-clustered index on the yellow pages, and then there's the index scan on the white pages that I created. But there's a sort here, partially because what SQL has to do is once it gets the filters done and says these are the rows that you want to return, it has to sort them based on the yellow page ID to be able to merge, or to join with this one to be able to get it back. But that's pretty much how are you going to, best you're going to be able to get with that query. But if we add the state to the index, how is that going to affect our query? Because now we're going to be querying by two different states, not just one state. And if we go down this execution plan, it's the same execution plan. We've used index scan with the index seek. And my last example is we're going to add the state to the white pages query, because we're also going to be adding the yellow, we're going to be searching on the where clause from the yellow pages of the state of Alabama. So we're going to add that query, run our index again, and it's pretty much as clean as it's going to get. We have the non-clustered index on the yellow pages, the non-clustered on the white pages. The yellow pages have to be sorted first before they can merge and finally get our select. The last thing I want to talk about real quick, or excuse me, the second to last thing is compile warnings. Compile warnings are execution plan operators that are given warnings to your query to say, hey, something may be up. So I'm going to do this one. I'm going to join these two tables based on the zip code and pull back the information. And I'm going to do that again. And if we look at the execution plan, this is a query operator compile warning. This is telling me that there's a problem. So if I look at the problem and I look at the warning, it flat out says a cardinality estimator. And it's a convert implicit of an invar on the zip code column. Well, if I look at the two white pages columns, I notice this table is all invar and the other white pages table are all varchars. The implicit conversion is telling you SQL has to spend time converting that invar on this zip code to a varchar on the other zip code. So the best way to do this is when you're joining tables, join with like data types. This is which will help remove this warning is if I change the column data type to a varchar on the second one. And then I run it again. You'll notice that the estimator is now, the compile warning is now gone because I'm joining two like columns. Now, one of the things that is interesting concerning this is the cardinality estimator was greatly upgraded in SQL 2014 and in 16. And it seems that if you if the compatibility mode of the database is in 14 or higher, we seem to not have this problem. There is no implicit warning on SQL 2014 or 16 because the cardinality estimator has been improved enough that it knows that it has to convert those and works a lot easier with mismatched data types. So I'm going to put this particular index on. It's an index on white pages based on the zip code and last name. And we'll see what kind of warning we get with that one. Compute scalar. The compute scalar is going to be a operator that has to use well, to be perfectly honest, that is not the right warning I was looking for. So, because that's not really a warning, that's just a thing. So, I'm not let me just move to another topic real quick, and I'm sorry about that. So, another issue that I've seen in the past is statistics. Statistics are the indexes that is the information that SQL uses to find the data, the probability of finding the data on what page. I'm going to drop all the statistics on this table real quick, and I'm going to show you one of the errors that I've seen. And I'm going to turn auto create statistics off. And if we use this now, you get this warning over on the index, which will tell you columns with no statistics. SQL uses these statistics to help find the data. So you have to have you don't have to, but the better operation of SQL is used with statistics. So if we turn statistics back on, run this one more time, that will go away. And if you look at the actual database on white pages, we now have statistics. The last demo was what I would like to do. It has to do with how do you determine the effectiveness of SQL. This is a query that we use quite frequently in my line of work, and it can be found just about anywhere. It's using this data, the DMV of database indexes, usage stats, plus the indexes and the data spaces to find out how useful these indexes are. And once again, I've got to go to the right database. And this will tell me exactly what the table, what the indexes are, some information about the fill factor, user seeks, scans, and lookups. And if you look, and the number of reads and writes. So this particular primary key has been scanned 24 times, looked up 4 times, read 28 times, and has 0 writes. Because I have not written to this database, that's why it is 0 writes. Databases that have more lookups than anything else, indexes that have more lookups than anything else are the ones that you need to concern yourself with. Indexes that have 0 reads and a whole bunch of writes, these are indexes you need to concern yourself with. That means SQL is writing more than it's reading, and the index is not worth it. You need to evaluate if that index is worth having the overhead of writing multiple times. And the way I can do this is I'm going to run this query a couple of times, which is just multiple queries and the same thing. And if we look back at, we can see 174 scans. So every time you read, it's going to read against the query. Rob? That's about all I have. Guys, ladies and gentlemen, thank you for your time. But remember, keys to using these things together. You need to plan out your indexes for multiple queries. Know what your queries are looking for so you can plan out your index. And look for those covering indexes. Be cautious on the SQL index recommendations. They have a tendency to be somewhat over-aggressive, and they don't take into consideration current indexes that are on your database. Look for the execution icons. If you learn what the query plan is actually doing and how it gets to the end, you can create better queries. Thank you for your time, and remember, this Saturday, August 6th, SQL Saturday Baton Rouge will be at LSU campus. Are there any questions?
Yeah, we have a few questions. To cover a few easy questions, I'll hit them real quick. We are recording the webinar, and I'm going to post it to YouTube. I'm going to try and get it on there Friday. And typically you can log into the data architecture chapter for PASS, and the archive sections, there'll be a link. They're also at SQLtigers.com. I'll try and post some information. I did have a question. A few people were asking, will you share your demos? We can post them on the website if you'd like.
I will gladly share them to you guys, and I will share them on my personal blog as well.
Okay, great. And let's see, I'm kind of scanning through here, through the questions here to make sure I got them all. So here's a question. What if you can't change the column type and have to join two tables? So they're kind of like, what if you're stuck with what you got and you can't change the data types, you know?
You can manually convert by using a cast or convert in the where clause, but that can be problematic too. Sometimes you just have to work the queries with what you have. A lot of times, I see more in-bar cars with ETL processes that take data from other sources and put them in SQL, because the default for Excel and OLDB and all these jet drivers is nvarchar. And it's a simple thing of just adding. But if you can plan out these things properly, it'll help greatly.
I'm not seeing any other questions. So if y'all have questions, email me and I'll make sure Robert gets them. And I really want to thank everyone for coming today. We had a late afternoon presentation, and if y'all like this later afternoon presentation time, please email me and I will schedule more for this later in the afternoon time frame. I kind of actually starting to like it. So if y'all want to continue, I'll be glad to continue this time frame. So I'm not seeing any more questions. Does anyone else have a question before we close it down? No, I guess not. So, Robert, thank you. We had a lot of people show up. Over 110 people showed up. I'd like to thank everyone for taking their afternoon off and coming in and watching the webinar. I thought it was great. And I look forward to seeing everybody at SQL Pass in Baton Rouge. And please stop and say hi to Robert if you're there, or me, Rob. So thank y'all, and y'all have a great day. Thank you, Robert, again.
My pleasure.